Have you ever been on a plane, thousands of feet in the air, looked out the window, and just thought, how is this massive metal tube staying up here? Why aren't we falling? It's a great question. And the answer is a fascinating mix of physics that people have debated for over a century. Today, we're going to settle that debate. Is it Bernoulli's principle or Newton's laws that keep planes in the sky? Let's start with the classic explanation you've probably learned in school. Bernoulli's principle. This idea, from the 18th century Swiss mathematician Daniel Bernoulli, says that as the speed of a fluid like air increases, its pressure decreases. An airplane wing, or an airfoil, is cleverly designed with a curved top and a flattered bottom. As the plane moves forward, the air splits to go over and under the wing. Because the top surface is curved, the air traveling over it has to cover a longer distance in the same amount of time as the air going under the wing. To do this, the air on top must move faster. According to Bernoulli, this faster moving air creates a zone of lower pressure above the wing, while the slower moving air below maintains a higher pressure. This pressure difference creates an upward force. And what do we call that force? Lift. The high pressure below literally pushes the wing up towards the low pressure above. Simple, right? Well, not so fast. It's not the whole story. Some critics point out that the equal transit time theory, the idea that air molecules must meet up at the back of the wing at the same times, UN strictly true. In reality, the air on top moves much faster than needed just to catch up. Also, how does this explain planes flying upside down? If the curved part is now on the bottom, shouldn't it create downward force? Yet, stunt planes do it all the time. This is where our other contender, Sir Isaac Newton, comes into the picture with his famous laws of motion. Let's focus on his third law. For every action, there is an equal and opposite reaction. Think about the wing again. But this time, think of it as an object that hits the air and pushes it downwards. The wing is angled slightly upwards, what's called the angle of attack. That's the same principle. This explanation perfectly accounts for upside-down flight. It will generate lift, no matter which way up it is. It also explains why a simple flat plank of wood can generate lift if it is angled correctly and moving fast enough. So, who's the winner? Is it Team Bernoulli or Team Newton? The truth is, it's not a competition. They are two different ways of describing the same physical phenomenon. You can't have one without the other. Bernoulli's principle accurately describes the pressure differences around the wing, which are a real and measurable part of how lift is generated. Newton's laws accurately describe the overall forces at play. The wing pushes air down, and the air pushes the wing up. They are two sides of the same coin. Modern aerodynamics uses complex equations that incorporate both concepts to design the incredibly efficient and safe wings we have today. So, the next time you're soaring through the clouds, you can relax. That plane isn't staying up by magic. It has stayed up thanks to a brilliant partnership between the pressure games of Bernoulli and the fundamental action-reaction dance of Newton. Both are working together to create that amazing force called lift, turning a potential fall into a graceful flight. Thanks so much for watching. If you enjoyed this little dive into the physics of flight, don't forget to hit that like button and subscribe for more answers to your biggest questions. See you in the next one.